Welcome to the video about inverses. This first video is going to be really short, and I'm going to basically just introduce the word inverse to you and give you a few examples of functions that are inverses, and then also a few non-examples, and then finally end with a sort of a graphical connection. So on your screen you see right now two functions, f of x and g of x. I claim that they are inverses of each other, and by that I mean if I take f of, let's say, 4, I get 2 times 4. 2 times 4 is 8, plus 3 is 11. An inverse basically undoes another function. So if g is in fact the inverse of f, if I take g of 11, I should get 4. That's really what an inverse does. Let's check. So if I plug in 11 here, half of 11 minus 3 over 2. So I'll just do some simple arithmetic here. 11 over 2 minus 3 over 2, well, that's just 8 over 2, that's 4. So you can see g of 11 is 4. F of 4 is 11, g of 11 is 4. When that's the case, these are inverses of each other. So you can call the function g, you can actually say that g of x is the inverse of f, and vice versa. Inverse notation is this -1 exponent. We never actually say -1, we say f inverse, and vice versa is true as well. The function f is equal to the inverse of g, g inverse. These two, h and k. Alright, another example here. Let's take, I don't know, h of 8. If I plug in 8 here, the cube root of 8 plus 2, the cube root of 8 is 2 times 2 times 2, plus 2 is 4. So h of 8 is 4. That means if k is the inverse, k of 4 should be 8. Alright, you can see a nice symmetry here, right? Kind of crisscross. So let's check that. Let's confirm it. If I plug in 4, 4 minus 2, 4 minus 2 is 2, 2 cubed is 8. That's confirmed. So these two are inverses of each other. Alright, and inverses really, as you can see, they sort of just kind of switch the x and the y coordinates. And by that I mean, if you look at, let me jump down here to the graphical connection. If we jump down here, right, I've graphed for you the blue function and the red function, and those are inverses of each other. Alright, in one of my other videos I do just a pure graphing video on inverses, where we don't do any function rules at all. We just look at points, and we talk a lot about how a function and its inverse, they're symmetrical across this line y equals x. So in other words, if we were to fold our paper along that dotted line, the blue would match up with the red at every single point. Right here would match up over here. Right here would match up right here. 0 comma, this is an easy one to see, 0 comma 3 is equal to 3 comma 0. So what we're doing here, the inverses of each other just kind of switch the x and the y. Switch x and y. You switch them. 0, 3, 3, 0. Alright, and that's true of every single point here. And they're always going to be symmetrical across this line y equals x. Y equals x, of course, is just this standard diagonal, and it's here in a dotted line. So again, if you want more graphing connections, go into watch one of my other videos on the graphical inverse. But let me show you a few examples of functions that are non-invertible. Right here, I'm looking at just the standard parabola. Right, when x is 1, y is 1. When x is 2, y is 4. So this is y is equal to x squared. 0, 0, negative 1, 1, negative 2, 4, and so on and so forth. I claim that this function has no inverse. And the reason that it doesn't have an inverse is because when you take this function and you ask yourself, okay, is it what we call one-to-one? And what that means is, do I see any y values that are sort of repeating? Right? I know this is x is 1 and x is negative 1, and they both sort of output the same y value, which is positive 1. Up here, the y value is 4, so this would be negative 2, 4. And this would be positive 2, 4. So this does not cross what we call, or doesn't pass what we call the horizontal line test. Now you've probably used the vertical line test to test functions. This is certainly a function, but the horizontal line test tests something that we call a function being 1, 2, 1. Alright, if it fails the horizontal line test, it's not one-to-one. If it passes the horizontal line test, which is to say the horizontal line only hits the graph once, then it is one-to-one. Functions must be one-to-one in order for their inverses to be a function. So I guess technically this graph has an inverse, but its inverse isn't a function. Alright, its inverse isn't a function. Alright, its inverse would be, if you replaced all these values, its inverse would not pass the vertical line test. Alright, same thing over here, right? We're looking at this function right here. This is definitely a function, but and I know it's a function because none of the x values sort of spit out two different y values. It passes what we call the vertical line test. This is a function. I claim that its inverse is not a function though, because it doesn't pass the horizontal line test. The horizontal line touches the graph twice. Here it touches the graph twice. So it fails the horizontal line test, which means that it is not one-to-one, which means that its inverse is not a function. All right, most times you would say that it doesn't even have an inverse. Down here again, you can see, that's a terrible horizontal line. If this is a horizontal line, that's not even that great. My goodness. Let me change that to a line here. You can see that horizontal line touches the graph at 3 points. 1, 2, 3. So this function is not one-to-one, and therefore it doesn't have an inverse that is a function. All right, functions that have inverses must be one-to-one. All right, an example of a function that is one-to-one, something like this. If we throw a horizontal line through here, it only touches once. It only touches once. So that function right there is one-to-one, and if we wanted to put in this imaginary line here, this line of symmetry, y equals x, you would see that all you would have to do is take all of these points, let's say this point is 2, 3. Then a point on its inverse would be 3, 2. If this is 2, 3, a point on its inverse would be 3, 2. Somewhere in there. 3, 2. Alright, let's do a few more. If this is 0, 2.5, then a point on its inverse would be 2.5, 0. If this were, you know, negative 4, comma 0 right here, a point on its inverse would be 0, negative 4. 1, 2, 3, 4. Somewhere down here. All we're doing again is we're switching x and y. Alright, so this thing would graph, and it would be reflected over y equals x. Let me see if I can draw something that kind of looks like this. It's not going to be great, but something like this, and then they'll come together right there. It's not too bad. Alright, at this point right here, they come together. So there's a little brief introduction to inverses. In another video, again, I did more about graphing inverses, you know, with more stuff like this. And in a next video, I'm actually going to come back to some of our function rules and show you. In this video, I gave you the inverse, right? But now, in our next video, how can we find that? If we're given a function, how do we find its inverse? That's where we're headed next. So thanks for watching, and make sure you subscribe so you don't miss any videos.